Hey guys, welcome back. This is Tim from Tim's Electronics Lab, and today we've got a short video showing how to recycle batteries from a laptop battery pack. Now, a friend of mine gave this battery to me. It's a ASUS lithium-ion battery pack. I think this one contains 8 cells, because the previous one I torn down was about the same size. So yeah. This gives me plenty of hope, and batteries of course, which is the main thing. Now there are a couple of ways you can open this. One that I've seen and I found to be very effective was just by turning them. It's a little raw, especially with bare hands, but let me try to do it. And not with this battery. You can feel it quick enough if this battery, if your battery is able to let go or not. Now there are a few tabs here and there. I firstly recommend you to remove any label, because a tab might be hidden under it. Just like here. Oh no, that's not hidden under a label. But this is a tab, I am guessing. Oh, this laptop is sealed, this battery is sealed better than the last one I opened. I think this is a newer battery, which is a good thing. Now, please keep in mind that you will destroy the outer cover of your battery. And also, this is at your own risk. If the batteries cause fire or something, it's like I said, it's at your own risk. Now, right now, turning still doesn't work. Sometimes you need to release the glue, and then twisting the battery might work. Oh, these are blue 18650's. I've never seen that color. I think they're made in all colors, so not very special, but just the cover part. Oh, Samsung. Ah, nice. Samsung 18650's. So you can use a bit of force. I suggest you to try to keep the battery in one piece. So not like this, because you risk shorting the batteries, and it is it's better because you've got a strip that you are able to solder connections to, and also make sure not to poke the battery. The battery sleeves, I think that's how you call them, because that will expose the ground plane, which is rather big, of the battery. And I already accidentally touched a ground plane with another battery, and yeah, well, it didn't caught fire or something, but there was a little spark and a very unsafe feeling at my side, because I don't want to have a lithium fire or something. A 8650 battery exploding in my bedroom is not really healthy, I suppose. So that's what you don't want. But what you do want is this. Just use some force and eventually it will come off, just like that. Now the batteries are held in by call it stickers to the case. So just pull them off like that. You can remove it. Now I failed at not screwing up the battery, but I am lucky with not screwing up the battery connections, which is important. Oh, this plus cable is rather big. Now, oh, this circuit board is not conformal coded. The other battery I teared down, the whole circuit board had some kind of glob all over it, all over the chips, to make sure that shorting wasn't possible. And it's some kind of, I don't know what this is. It looks like, maybe it looks like a fuse of some kind. I'm not sure. A lot of transistors and such. Charging and protection circuits. Alright, so what you can do is you can desolder the wires from the battery circuit board. That's what I did with my previous batteries. As you can see right here, I've desoldered them, but since there are pretty good wires, I'd like to save them. Well, one of the terminals, because you can't have both. So let's cut this. Oh wait, let's first measure if there's some voltage still on it. So like that. Let's put some load on the battery. Ooh, excuse me. So plus and minus. Oh, 15 volts. Oh, not bad, not bad. So there's still some juice in the batteries, which is good and bad. It shows that the battery is in reasonable condition. It's also bad because we are just cutting raw wires and we could take the risk of shorting. Now here you can see the temperature probe for the battery, and it noticed me with the previous battery as well, is that only one battery, well, pack, if you call it like this. You know, one group of batteries is only measured the temperature of, not the other three. So if this one goes wild, you know, you could already be too late. I'm not sure. Maybe it's a little more advanced than I'm thinking. Remove the balancing connectors like that, and of course the temperature, and there you go. There are your batteries. Now, you might want to have them stay in one piece, like this. So you can have a 16.8 volt battery. Now the battery was at 15-ish volts, so it's reasonably charged. So that's good. It's really good. But I'm going to take them apart. Oh, I'm glad just a little. Because that's better for sensors and all that stuff. So remove the tape like that. Now this is a thing you need to keep in mind. What you don't want is to solder directly to the battery. If you can, you need to avoid that. So I'd like to keep on the metal plates over here, the contacts. And since this wire comes out here, I'll try to cut it as short as possible to give this battery pack as long as possible of a contact to be soldered to. And same goes for this one. This one has a contact and this one doesn't. top one, so got it right here. And yeah, it's unnecessary to say, but the same goes for the following battery. You cut it right here. See, this has a contact and this one doesn't. So, alright, now that's good. That's all hunky-dory, as Mr. EEV Block would say. Now, it's time to measure the... Ooh, my screwdriver just came with the millimeter. Now it's time to measure the individual cell voltages. So again, put my meter on a load mode that puts some load onto the batteries. And let's measure this one. It's at 3.8 volts, which is good. Not low, it's not high, it's perfectly fine actually. It's a good sign of a battery that is stable and it's still working perfectly as it's supposed to. And that's what we want. So this is alright. Now the next one. Also alright, I think this battery is well balanced actually. And this one's going to be a little trickier because they've put some plating on top of it. Just so damn, it's strong. Oh, that's because of the tape. Let's hold it down. So, cut it. There you go. Oh, shit! I cut the. Oh, it was inside. Ah, now I know. I just cut the metal trace to the other battery. But hey, oh shit. Those things happen. Obviously. Now I'm going to attempt to resolder it later. Just measure the individual voltages of the cell. Like that. 3.8. 3.8. So this is fine as well. Thankfully. And also 3.8. So this battery was well balanced, actually. Very well balanced. I have a suspicion that it just came from the charger. And it was balance charging itself to a level that it was feeling fine. So now there is a other thing what to do when you've got batteries that aren't charged perfectly as these are. So what you need to do is get your lab bench, and I need to find batteries that have this one, both clips on both ends. And of course clip the negative to the negative and the positive to the positive. Make sure that the positive doesn't touch the negative. I know, but it happened to me a few times. Switch the multimeter back to normal voltage mode, since an extra load is not necessary. And plug it into the banana plug leads thingies of my power supply. Now what you need to do is take a look at the data sheet of this battery. The battery, Google the part number and take a look at the charging voltage and maximum amperage. That's very important because you need to set them. Now enable, I first need to enable a channel. Now the channel is not enabled now. Well, it's on, but it's not enabled. It's active, so you can set the voltage, and the voltage needs to be set at 4.2 volts. No more, but certainly no less, because that's the specification that the datasheet shows. I already know this specification. So now turn on the channel and increase the current flow till the limit of the battery, and as you can see, it's around 1 amps. The battery doesn't go above 1 amp, and that means that the battery is now at the constant voltage, in a constant voltage mode, where the state where it well, it's about to get in constant voltage mode, because I'm sure that 1 amps that this is drawing right now is not the maximum that this battery is able to draw. So yeah, let's quickly disconnect it. Yeah, you can increase the voltage a little, so you have 4.2 volts at the output. And the amperage rises with it. So now the battery is drawing around 2.2 amps, which means it's still in constant current, in its constant current phase. So you need to limit the current and make sure that when the current is unlimited, you know, it's not held down by the constant current protection of your power supply. The output voltage is around 4.2 volts, which it should be around right now. So you see the current dropping on the I will make a quick video. So you see the current dropping on the display. That means that the battery is charging. You can see it's around 4.54 volts at the output of the power supply, but it's around 4.2-ish volts at the multimeter. So now it's at this voltage, and that's the time you need to slowly decrease the voltage. Oh, it's got some kind of threshold or something, because now the current drawing drops to virtually nothing compared to the previous state. Yeah, this is about the limit, charging voltage limit. You need to adjust the current limit so that the voltage isn't going to be above 4.2 volts. Now you could buy a professional battery charger, but since I don't have one, I'll just use my trusty power supply, which features another channel. You can set it individually and you can turn it off and on, like that. Yeah, the LED's faulty. You know, if I tick on it, sometimes it went off. Well, not this time. But you can set it individually, and that's cool, because now you can adjust the voltage when the output is off. Now when you have switched off the output like this, the positive and the negative wires are fully disconnected from the power supply. This is a double pole, double throw switch, so it means that they're both fully disconnected from the power supply. So that's a really good thing, because now you can ensure that yeah, your power supply is isolated from the output. But back to the battery charging. You want to do this until the battery has reached a voltage of around 4.2 volts. Look, now I've disconnected it, turned the power supply off, and when I remove the leads, nothing happens. Really nothing happens. And now the power supply is turned on, of course, with the ground lead removed, and nothing happens until I connect the ground lead. And if I remove the positive lead, of course nothing happens. Oh, that's also the ground lead. So yeah, brief overview of my power supply. So again, like I said, you need to charge the batteries once they're at 4.2 volts. Then they're charged. This is a good way on doing it yourself, but there's one important catch. You need to keep an eye on the battery and the battery voltage. It's not like just plug it in, turn on your power supply, and you can leave it until they charge, because that will damage the batteries, and it has the ability to blow up in or at your desk, and that's the thing you don't want. So now what you could do with these is just like I've shown in the previous video, buy a lithium-ion battery protect circuit and solder the B plus and B minus to the positive and negative side of the battery, and this way it will prevent the battery from all things, including short circuit. So if you fully short circuit your battery, nothing will happen, and I've just tested that. Really nothing will happen. The voltage will drop down to around 0.1 volts, which is nothing basically. So that's a very good thing, and it will protect against over discharge, overcharge, and all that kinds of stuff. Now there's one thing I need to say. If you keep pumping in power through a solar panel, I'm not sure if this thing will protect against overcharge. You know, because it only has a limit on how much power it can dissipate. Just like the capacitor bank protection circuit that Julian used. It only has a limit on how much power it can dissipate. So if you put, let's say, 10 amps into this, then your battery will probably be dead, and this one will be dead too. And the battery is full, and you keep pushing in 10 amps. Let's say both survive, and you keep pushing in 10 amps, then it will most likely exceed the power dissipation limit of this chip, meaning that it won't be able to protect against overcharge. So you need to keep an eye on that, and you might as well solder 1 or 2 more LEDs to the blue LED. One of them is blue, and that will stay on when the battery protection, battery charge protection is active, to pull some power from the battery to make sure that it doesn't overcharge. So, quick video about 18650 batteries. I received a comment of to ask how I bought them, or where I bought them, if I've got a link, and I already responded to the comment saying no, I don't have a link. I salvaged them from old batteries. Now what you could do is just say to your friends, hey man, if you got an old laptop battery, I'm interested. And then you get cells like these. Now older batteries are interesting because they've got more cells. We're at the point that the microcontroller doesn't really consume that much power, so These cells are probably around 1500 milliamp hours, which isn't a lot at today's standards per cell, because the maximum capacity is around 3000 milliamp hours. So these are half the capacity. That's why you need 4 instead of 8, because most laptop batteries will feature 4 cells nowadays. But just say to your friends like, hey man, I need a laptop battery, so if you have one, please give it to me. And the older the better, until a certain point of course. So yeah, just like I said, this was an old battery, it gave me 8 cells. And with that ending, I'd like to say thanks for watching, and I hope to see you next time. Bye. Thanks for watching this video. I hope you've enjoyed it. If you did, please leave a like. Make sure to leave a comment down below. You can also share this video with your friends if you think they will like it too. See you next time.